Hi and welcome to TX Bench. Today here on the bench we have a Kenwood receiver R-5000 and the radio or the receiver came in with really doing nothing. Radio is completely dead, so what has happened to the radio? Let's see and let's go into the video. Okay, and here it is, and yeah, it was really a famous receiver at its time, and so it makes really sense to check out if we can bring it back to life. So for the moment, as I already said, there is definitely nothing. So radio is already here connected to mains, right? And well, when we try to switch it on, nothing. So it is definitely absolutely dead. So therefore, directly we have to crack it open and try to find our way through. Alright, so lid is off and let me bring it here in a better position for you. And okay, so that is our first look. So what we find is a linear transformer, and most likely, yeah, it is more or less sure. So that is our power supply PCB, and well, so what have we else? So that is the 2 meter module, but what is that here? So that is not connected here to where it should go. So let's see if I can show it to you. So there we have our connection or our connector down there, but it is not connected, and somebody wrote down 2 meter and an arrow, whatever that means. Anyway, so that was an extension, and that was very nice at its time to have the 2 meter module. Anyways, so first what we need to find out how here our power supply is working, and yeah, what can I see else? You may see it maybe a little bit. Let's see. Not really. But down there, that is a rectifier. So it is really a big rectifier which is built in the radio here. And well, we have as well here on our PCB, we have 2 fuses, and of course that is what we start with. So that is definitely the first we should do, and if we are really lucky or unlucky, however you want to call it, it is only a fuse. And even if that is interesting as well, that you see that sometimes really it makes sense to check at least you know, the fuses. So therefore let's start with our fuses. Okay, so I've repositioned the camera a little bit, and now I have here my probes, and of course we are on beeper mode, and let's see what we have. Let's start. Okay, so this fuse seems to be fine, and this fuse here is open. Looks like that the fuse is open. So let's see if we can lift here the fuse like so, and let's do the test again. But No. So that fuse is dead. Okay, yeah. Okay, so that is fuse 1. I mean, what we can do is we can simply put a fuse back here into it, and we can try it. But maybe there can still be a short which would blow the fuse once again, and therefore let's see if we can get an idea how it is working and what this fuse does compared to this fuse, which is just fine. So, because normally a fuse always has a function, and it is very seldom that a fuse blows by itself. I mean, yeah, okay, that happens from time to time, but that is more often when you have a lot of mechanical yeah, maybe vibrations in a car or what, then maybe it happens unpredicted. But you know, in most cases there is a reason for why a fuse blows. So therefore, let's try to get an idea how both fuses are working and what they are for. Okay, and I found here in the block diagram our portion, our power supply portion. So let's see if we already get the wanted information from here. Let's see what we have. Okay, so what we have here, of course, that is our transformer, and we have here our F2, which is going here over our rectifier into our power supply board. And what we can see here, that we literally have 4 different voltages for the different purposes here in the radio. But we only see one fuse, and we don't know. Okay, so that is F2. And F2 is not the fuse which has blown. So according to what is printed here on our PCB, the fuse which has been blown is F1. It is F1, isn't it? Yeah, it is F1 for sure. So this will not really help us. I mean, it will tell us that we need 4 different voltages to run the radio, but that's it. So we need to go ahead and hope that we find a better idea on what's going on here. Okay, and that might help a little better. So what we see here again is our transformer. But I believe we have this version here because we can adjust for more than only 1 voltage like this. So this is for United States services only, and here we have different voltages. So what we have here is not the K-type anyways. When it comes here to secondary side, it is completely similar, right? So what we see here we have our F1, and we see that, yeah, that is funny. Our transformer output is running here over our PCB through our fuse which has been blown, and then really goes here to the rectifier, right? And the second wire directly goes to the rectifier, and we have finally then plus and minus. Plus is here the bolt line, and there we find our F2, and F2 has not blown. So maybe the radio can be operated here over our DC connector, because the radio can also be used in the field, and you can connect here a battery to the radio. And the only difference we have is that, of course, we do not need our rectifier, we do not need our transformer, and therefore we bypass here our F1, and you see here D1, which is working as protection diode. And yeah, so therefore maybe our radio runs over our DC jack. So therefore maybe it is a good idea to check that first, because if and that is what have blown, that could be potentially due to a faulty rectifier or a problem with our transformer. But I mean, okay, also this fuse could be not that fast like the F1, so therefore of course it could potentially also a problem here in this portion of our circuit. Well, I'm going here a little bit slower just to explain it a little bit, how you can approach problems like this. Most of you would simply place a new fuse and would yeah, try what's happened, and yeah, if you're lucky it works, and if not, yeah, then you have exactly to do what I have already started with, analyzing the circuit. So, and that is what it is all about. So if you want or if you need to fix an electronic device, you always have to analyze the circuit, you have to understand it, and then you can make your own plan how to approach the problem, where you start with probing to get results which finally leads you to the problem, right? Okay, and as you can see, I have taken here our AC connector off, right? And I have here my leads put to the DC input, and that is what we want to try right now. And of course I've checked out here the polarity, so do not mix it up. So that is never a good idea. And now we try if it works simply by using an external power supply. Okay, so therefore I switch the radio, wire our switch on, but our power supply has not been switched on yet. So therefore let's try to do it this way. Now I switch here our power supply on, okay, but our voltage is completely down, and I go now and try to increase here our voltage, and we of course check here the power consumption. Well, have a look. So it seems that our radio is coming up. It is coming up. So there, okay. You hear that? That does not really sounds very good. So that could potentially mean that there is another problem, but maybe it is too less current which has been dialed in. So let me do it once again. Yes, so that was simply because we had not enough power, and you see our radio is obviously working so far. Okay, now let's go ahead. Okay, so since we know that our radio is obviously working, so you can see it and we hear that we have static. Of course, we can now put simply in a new fuse. Interesting to see if we go over here to our power supply. So 1.5 amps is quite a lot for only receive, and here when I switch the radio off, now you would think it is completely disconnected from our power supply, but you see there are still 300 milliamps which are somewhat flowing, and well, 300 milliwatt is quite a lot. Many radios running with only 300 milliwatts on receive, and as we see, this is using 1.5. I mean, that must not subsequently means that it is wrong, but let's see if we find the specs. Okay, we have the specs, but unfortunately our datas here are only telling that the radio will take 35 watt power consumption, but that is under AC conditions. So therefore we cannot completely evaluate that, so we would need to transfer it over the transformer anyways. So let's simply put back a new fuse and let's see what that means. Alright, so let's simply put here a new, and it is a fast version. So you have 3 different types. So slow, middle slow, and fast, and that is here a fast one, which is required. Very nice. Very nice. That is how it goes always. So gone. But yeah, we will win the game. Okay, so let's put it in. Very nice and very easy, no problem at all. And let's see. Okay, so I have of course to take off here our DC, and now we put back AC. Alright, but it is not connected yet or switched on. Alright, so let's go down, and now I'm really excited. I switch this out. Now we switch our isolation transformer on, and now let's see what happens. Whoa, it's running. Ha! That was easy, really. So I still don't know why our 2-meter wire is disconnected. I don't know. Well, let's see what happens if I put it back in. So really do not have a clue, and I didn't get an information about that. And now, what is going on here? Something is funny. Okay. Our pots are obviously a little bit dirty anyways. So Hey, what is that? Is that only our potentiometer? Maybe it is dirty. That is funny. I have no information on that either. Anyways, now I've turned it down. I just want to put back here our 2-meter converter. And let's see what that means. I have to do it off camera. I have to go around. Okay, so that is in, and no problem whatsoever. So that is not producing a short. Okay, so let me connect here the generator to it to see if the radio in general is working. Okay, so it is receiving just fine, as we can see here, and as we can hear, so no problem whatsoever. And let me switch it off. Our figures here are also just fine. So let's see if we check out for sensitivity. And yeah, let's go for 12 dB, and our generator already starts working. And so also that seems to be very nice. So we have still our signal, you can hear it. So we are, I was asking for 12 dB, and you see with we can get it with minus 123, 124, which is definitely an excellent sensitivity. So no problem whatsoever. So of course we have to do it on SSB as well, but well, I do not need to show it. You have seen it very often in my videos. And now I was of course interested in the 2-meter band, and it is also very nicely working. So I'm still on minus 123.9 dBm. So as we know, that is a very low level. So let me increase here our level to, let me say, minus 93. So come on, minus 93. So we all know that the figures are a little bit different to HF. And we see a nice S9 level on minus 93 dBm. And we have a beautiful signet of 43 dB. So on the 2-meter module, which is the one here on it, is it working as well. So definitely no problem. So I will put here some spray here to our AF control, because yes, you can hear it. It is a little bit dirty, but that's it. Okay, there is really nothing more I can show you, and really the question is it worth to put a video like this on the channel? I mean, literally it was a faulty fuse, and we see that there is no additional fault, so we do not know why you know, the fuse was blown. But obviously our radio is working just fine. And yeah, when I check here my power consumption, it is 27 watt, and we have seen that the radio is indicated here for 35 watt maximum power consumption on or in the specs, and you see we have here 27. Yeah, we have 27 watt, you can see it there, and we have 140 milliamps, which makes sense as well. 35 watt would be 160, so we are a little bit below. You know, all is just fine, so radio is running in its specs, so, and yeah, it makes really a good impression. Okay, finally, still the question, is it worth to load it up? Honestly, I don't know, so that was nothing, but on the other hand, maybe some of you who are new to the hobby might get some basic informations as well, and therefore, if you never have seen it, and if you never got a feeling on how to approach something like that, and even it is only a fuse, the video might be helpful. And well, if you are advanced radio operator, so that is nothing new to you, but yeah, well, I think I load it up, and you can put your comments down below here under the video, and you can tell if we should load up even yeah, videos like this where you only have some basic understanding, or maybe it is not worse or it worse. So your comments are highly appreciated. Okay, thanks for watching, and catch you next time. Bye.